now that we've taken a look at piecewise functions and we've kind of had a basic introduction to them, you may be just a little bit confused as to what they really are and what they really look like still. So for this particular example, we're actually going to graph a piecewise function, and this will give you a better sense of what they look like on an actual graph, and it'll give you the clear vision of why they're called piecewise functions, because you'll actually see the two pieces of the given function. So let me take you through a few steps here in example 2 on graphing this piecewise function. So you can see here that we have f of x equals these two parts of lines based off of the condition x is less than 1 and x is greater than 1. So what we're technically going to do, and everybody kind of has their own method about going and doing this, so if what I'm doing doesn't fit you perfectly, maybe discuss with your teacher an alternative method to actually graph these things. But what I tend to like to do is I like to graph both lines completely. And so I'm going to actually graph 1/2 x plus 3/2, and then I'm also going to completely graph negative x plus 3. Now, if you're doing this on the computer, the method that I'm suggesting can be a little bit difficult, because what I'm going to do is I'm going to actually graph the entire line, and then I'm going to erase the part that I don't want. Now, if you understand this process, you can totally bypass that step and just graph the piece that's easiest for you. But just kind of see me out and hear me out, and see if you can kind of connect with what the end objective is. So what we got going on here is I'm going to graph y equals 1/2 x plus 3/2. So 3/2 is, I'd say, part of the way up, 1.5 blocks up, and then I'm going to go up 1 and over 2. So I'm going to go up 1 over 2. That'd put me right there somewhere. I can go down 1, backwards 2. Excuse me. That's going to put me about right there. And I'm going to just use the little highlighter function here, so I could actually graph that line going all the way through just like that. Now, I'm just going to go ahead and move on to the other one as well, and then I'll come back to the piecewise part. So if I want to graph negative x plus 3, I'm actually going to go up 1, 2, 3, and I'm going to have a negative 1 over 1 slope. So I'm going to go down 1 over 1, down 1 over 1, and so forth. And then I could graph that. Now I'm just going to use this little highlighter tool. And so you can see here clearly that when I do that, I don't pass the vertical line test. I have these overlapping x values that are being repeated between the two lines. And so I really need to eliminate a piece of each of these graphs. Now, what we're going to do right here, this one right here, is really going to kind of create what we call a boundary line. So I'm actually going to just draw a little dotted line to represent a boundary at 1. So I know right there at that level that I need a piece on one side of that, and I need a piece on the other side of that. Okay, and so let's take a look at this. It says I'm going to graph 1/2 x plus 3/2 for all the x values that are smaller than 1, less than 1. And so all x values that are less than 1 are actually over here on this side of the graph. And so I need to graph the part of the line right there that is on this side of that line. And so I can kind of erase that highlighted part. Then I need to graph negative x plus 3 for all of the x values that are bigger than 1. That's everything on this side of the line. So I only really need to graph this part right here, and I can get rid of this highlighted part. As a result, what you see is we have one piece of the line on the right side of 1 and one piece of the line on the left side of 1. And oddly enough, they actually intersect right there on 1. So that's kind of a unique situation right there. Now, you can clearly see between the red and the blue graph that we have two pieces of two different functions, but this is considered one function together. So these two parts actually go together, and they're called one piecewise function. Okay, give it a shot on your own. Sample problem number 2 is a little bit more involved. There are little nuances, but I want you to go ahead and try it on your own first. and then I'll come back and I'll talk you through it and see how you did. So go ahead and pause the video and try sample problem 2. So what I'm going to do here is I'm going to simply graph these two lines. So I'm going to start off simply enough with 2/3. So I'm going to go up roughly 2/3. That's not a real pretty y-intercept. And then I'm going to go up from there 1, 2, 1, 2, 3. So that's a rise over run of 2/3. And then I can go down to 1, 2, and then go backwards 3. And so I more or less get that line roughly, and I'm going to come back and fill that in. Don't worry, I'm not going to leave it like that. The second thing I'm going to do is I'm going to say y equals negative x plus 1, so that's up plus 1, and man, that's almost right on top of that other point. I'm going to use a different color. And I'm going to go down 1 over 1, down 1 over 1, and I can graph that line as well. And again, I'm going to just simply use a highlighter. I'm not going to leave it like that. Now, you can clearly see that that's going to create a vertical line test issue. So what I'm going to do here is I'm going to look at my boundary. And my boundary in this case is a +2. So at +2, I'm basically creating just a barrier that I need to graph the two pieces on. So we can see on this one, 2/3 x plus 2/3, I need all of the x values that are bigger than 2. So I'm going to take that original line that was roughly right here, and I'm just going to continue that in that direction. Excuse me. And so if I had a straight edge, this would be a lot easier. So use a straight edge as usual. We ask you to do that. Computer's not being very cooperative, but you get a sense of what that's supposed to be doing. And then I don't need that highlighted part, and I surely don't need the additional points on that side. Then I'm going to graph the x value for negative x plus 1 for all the x values less than or equal to 2. And so that's going to be, and again, straight edge would be useful here. So be sure to use a straight edge when you're graphing this. Now, let's take a look at this one final part here. We have two pieces of these graphs, and we've got the right parts. But we have one final thing that we haven't addressed here. We need to actually deal with the 2 value itself. So at x equals to 2, we have the line, the barrier line, or the boundary line, if you will, that are being touched by both graphs. So we need to represent one of them as being equal to 2 and one of them not being equal to 2. So let's take a look. For the second line, x is less than or equal to 2. I know that I have that point right there, equal to 2. So if that one's equal to 2, what it tells me is that one on the red line cannot be equal to 2. And if you remember from graphing inequalities in Algebra 1, whenever it was not equal to a number on a number line, we used to represent that with a little open circle. And so that's how we're going to do it on piecewise functions, and this avoids the vertical line test because you're not having a repeating x at 2. So that's what a piecewise function looks like.